I'm going to start with a little bit of history like Nathan did. I'm going to take you to a different dark age, the data dark age. So if you remember 2008, if you put on your Wayback hats, things were changing in data. So for my part, I'm using a lot of sequencers, and Illumina had just come on, and Solid. Forgot about Solid. And so Illumina had just come on the scene, and suddenly we were getting all these data. But that wasn't just me, that was the astronomers too, with their upward-facing observational telescopes. That was the oceanographers with their sensor networks out in the Pacific Ocean. A lot of us suddenly had experienced the data deluge, right? And we were talking about big data. This is the common buzzword that everybody was using. Although the term data science was invented in 1960, it really didn't start getting used until basically 2010. We were struggling with big data, but it wasn't just big data, right? It was the complexity of the data that we were getting, the velocity of the data in the case of people using like Large Hadron Collider data, and also veracity in terms of, say, social scientists that were getting data from sources like Twitter that had mixed veracity. We all congratulated ourselves for actually being able to generate the data and then stared looking at each other realizing we didn't know what to do with all these data, right? We had no way to extract knowledge and actionable information from these huge data sets that we had collected. So a group of us got together in 2008, all across campus, as I just mentioned, astronomers, oceanographers, I'm a chemical engineer. Some of you folks were present in the audience too, and got together and literally sat down in a room for several days and tried to understand what was missing in order to move forward with these data. And one of the things that we identified was that there's a set of educational goals that were missing in order to make use of these data, and that there wasn't a research endeavor in this space, much less a community. The core skills that we identified that would constitute a data science education on campus were going to be data management. Look, if you've got data, you have to manage the data. Whether it's in a SQL database or some kind of streaming data store, you have to have some kind of data management philosophy in place. Statistics, right? It's important to have students understand that the world is more than standard normal distributions. And if anybody who's ever used RNA-seq data is familiar with that, and that just because you find a correlation between two data points in a very high dimensional data set doesn't mean that they're causally related, like the number of people who die tangled in their bed sheets and per capita consumption of cheese in the United States. So having people understand statistics at a fundamental level so that they can use this and apply it to their big data is an important concept, but also statistics is the gateway to machine learning. And I'm not going to talk a lot about machine learning here. There's been a lot of opportunity to hear that, and there will be more while you're here. But understand that, again, most of machine learning begins with statistics or involves statistics in some way, shape, or form, and that's an essential component of education for our students in this space. And visualization, right? If I've got high-dimensional data and I want to share it with my stakeholder, my peers for peer review, my collaborators, I need to be able to visualize those data in a way that makes sense. And when we're talking about hundreds of thousands of dimensions potentially, this is suddenly a very complicated problem. And finally, one of the things I'm very passionate about, if you're doing those four other things, data management, statistics, machine learning, visualization, you're dealing with software, and we need to treat software engineering as a primary research product, or software that we create as a primary research product on the same level as a manuscript, as a patent, or as a data set. So these 5 things were decided roughly in 2008 at the University of Washington campus. We're going to make up this thing that was going to be called data science. Like CLEAR, the eScience Institute named ourselves a little early in this revolution, right? The term data science wasn't used, and we found this thing called eScience, and now nobody knows what it means, and maybe that's not a bad thing because artificial intelligence is a new thing, and we're not now named archaically, data science. Sorry, Sean. But time evolves and names evolve as well. So this philosophy that we had, which is to contextualize data science education in individual domains, applied as well to our research and community. That we were not going to own data science, that data science was going to be something accessible to the entire campus, and that we would remain relatively neutral in that space. So that fact that we have neutrality, by the way, that's the origin story for our logo. I love it when a logo has a good origin story. The fact that we're neutral is actually really important, right? If you go to Berkeley, there's a division of data science, and they own data science. That is not the case at the University of Washington. And the fact that we have a medical data science institute that incorporates so many different parts of campus, I think is another demonstration of that. CSE at the University of Washington does not own data science. Applied Math does not own data science, right? data science is in the domains. So that's a key feature of the eScience Institute. And that's emphasized by the fact that okay, I don't have my pointer, but it's emphasized by the fact that our 3 leaders are an astronomer, a chemical engineer, and an oceanographer. And the rest of the executive committee contains folks, again, from oceanography, anthropology, sociology, biology, and even English, right? So again, we are neutral. We are not owning data science as it is done in some other universities. We have an open physical space. If you haven't been to see us, we're at the 6th floor of the Physics Astronomy Tower in an old library space. It is really a really beautiful open space. You can drop in and meet with one of our folks. The fact that it is open and allows anybody to come in at any time means that we have a great water cooler effect process in place. And I can tell you probably $30 million of proposals have come out of the fact that people just show up and talk to our folks. We have put a lot of time and energy in creating career trajectories for data scientists in academia, both on the tenure track and on the non-tenure track, with a strong emphasis on people rather than infrastructure. So we have supported the hires of a number of folks across campus. And again, I want to emphasize that we have environmental and occupational health, geography, English as the kind of places that we're supporting. Next year, I believe we'll be bringing a new faculty in gender and women's studies as well. Again, all of these folks are doing data science. In terms of non-tenure track roles, we have a team of data scientists and research scientists that work in the eScience Institute. They are here to support you and your research, as well as having PI status and running their own research programs. And again, you can see they come from a variety of different domains. And hey, folks, for folks who are doing imaging of medical data, I have great news for you. There have been astronomers and geophysicists using satellite data since the late 70s and 80s who have worked out a lot of the imaging problems that you may be rediscovering, and the eScience Institute is a great place to learn from each other and share your ideas with them, and vice versa. Again, we have a team of research scientists who are non-tenure track that can support your research, as well as hundreds and hundreds of students and postdocs that we've engaged with over the years, including Vikas, who you heard about in Jerry's talk, was a postdoctoral fellow in the eScience Institute. I've talked about educational opportunities. One of the things that we have worked really hard to do is to create graduate options and undergraduate options and a minor at the University of Washington. So for example, in biomedical health informatics and education, you can get a PhD that has a data science option attached. And then we helped coordinate a number of the professional certificates in data science master's programs. Along with Nathan, we are helping to coordinate the AI at UW education working group, and if you want to be involved in that, please let me know. Our office hours is part of our informal education program. Anybody in this audience can show up and get time with one of our data scientists, absolutely at no cost to you. And then in the winter, we run a data science incubator program that, again, is at no cost to you, can give you access to 160 hours of a data scientist, including perhaps one of those geophysicists who's been using LiDAR data since the last 20 years, and you can learn some image segmentation methods from them. The kind of projects that come in here, there's no reason that they can't be health-related in our incubator program. We service the entire university. But again, we're more than willing to work with anybody, including the folks in this room. We have a 10-year plus seminar series, the University of Washington Data Science Seminar Series, that occurs weekly over the fall, winter, and spring quarter. And find our website. I'll show you the website link at the end to learn more about that. And we do a number of workshops, including software carpentry. So if you've been holding a pipette or a stethoscope for the last whatever number of years of your life, and you'd like to learn Python, you'd like to learn some basic software engineering, you'd like to learn some basic data analysis, every quarter we run a 4 half-day event where you can come in and learn those skills with us. One of the things that we strive really hard to do is to have all of our programs be both immersive and inclusive. And so immersive in the sense that you are in our infrastructure, in our arms here to learn something, and we're going to do that in the context usually of some kind of applied educational event. So we have this program called our Hack Weeks as a Service program. These are primarily sort of data-driven, data-enabled hack weeks used to teach various skills. So we run NeuroHack, AstroHack, Ocean Hack, Water Hack, Electrochemistry Hack. I don't know, Rob, have I forgotten any? I think there's a dog aging hack coming up. So the Hack Weeks is a service program. If you have a grant that needs a broader impact section and you want to create a Hack Week to promote awareness for the work that you're doing, we can help you organize those and run those and operate those. We have a focus on ethics and ethical research, including our Data Science for Social Good program that runs in the summer. This is a lot like our data incubator, except instead of 160 hours of a data scientist, we fund a team of students and several data scientists to work on a program, on a project, related to social good. And newsflash, human health and population health counts as social good. So this is a lightweight application process, 2 pages, and then working with one of our data scientists and our team of students to create a research project that we can support over the summer. Again, all of that is at no cost to you. We have worked with a number of folks in the community, so we're really excited to offer letters of support for folks. If you have a project that requires access to a data scientist, funded or unfunded that data scientist, we can write you a letter of support with that. We've done something like $100 million of grants through letters of support. We give out cloud credits every year. We've thus far given out $450,000 worth of cloud credits. I believe there's another $200,000 in the next year. And I see Rob Fotlin there. Rob, if you could just, Rob is the man on campus when it comes to learning how to use the cloud. And we've partnered with other centers on campus in order to help leverage funding. I hope that Nathan would say that we were helpful in bringing in his institute as well. As we move forward and look towards some of our new initiatives, we have been working to create this cross-campus thing called AI at UW in May 2022 in this exact same space without as good attendance, I shall add. This is great to see so many people in person. We did the first AI at UW event meant to discover actually who was doing AI at the University of Washington and then create partnerships and pairings between folks. We're planning the next one in May of 2023, so if you would like more information on that, please let me know, and I'm happy to provide it for you, or you can come check out our website. I'll show the link at the end. And as I mentioned earlier, Nathan and I and a number of other folks are creating an AI at UW education working group in the same way that we did in 2008 to describe what was going to become the educational goals for this thing called data science. We are repeating that process with, again, university-wide open process to decide how we're going to approach AI education on the University of Washington campus. One of the things I'm really excited about is our new Scientific Software Engineering Center. So this is supported by the Schmidt Futures Foundation. If you're not familiar, Eric Schmidt was a Google CEO for many years. And it's a campus-wide resource to data science and AI-enabled folks to bring professional software engineering expertise to the University of Washington campus. So some of you may be using software engineers right now, and you write them in for 6 months at a grant, and you try to hire one, and they're difficult to find. Well, we have a stable of software engineers that you can come and work with us, and we'll provide expertise, again, from professional software engineers for software design, testing, verification, documentation, and deployment, and community adoption. You can't just build a piece of software and throw it over the fence and expect people to start using it. I mentioned the Hack Weeks as a Service program that we run. Well, we're using that Hack Weeks as a Service program to help promote the software that we create on your behalf. As I mentioned, we're using professional engineers, so these folks tend to cost us a fair amount of money, but we help mitigate your cost by doing a 75% recharge. As an example of the kind of software engineers, our head of engineering is a 22-year veteran of Microsoft and most recently Microsoft Research. We provide a central, stable home for a group of software engineers, very highly skilled, diverse group of software engineers. And when you need a software engineer, you write it into your proposal, you write us into your proposal, and then we provide the engineering talent and management of the engineering talent. So now you don't have to go out and hire a software engineer every time. And let me tell you, if you're hiring a software engineer for 6 months, a year, maybe even 2 years, you are not getting the cream of the crop. I'm just going to be honest with that. And we can have those people and offer them steady careers and career trajectories, and then you can leverage that. We're thinking that most of the engagements will be 6 to 9 months in this space. And again, the goal is to help you turn your prototypes into open source software that other people can use or apps that people can use, again, to support your research. So if you want to learn more, please email me, and I will happily answer any questions that you have and get you plugged in with our engineering evaluation team. So with that, I want to close by acknowledging our sponsors and showing you the link to our website where almost all of the information I mentioned can be found, including how to connect with us and take advantage of the incubator, the Data Science for Social Good, the office hours, and the Scientific Software Engineering Center. And with that, I'll take any questions that you might have.